Alright, so here it wants to know what about springs. Imagine a very large mass, a spring, and a ruler. The ruler measures meters, so this is going to be 10 meters, 20 meters, etc. Okay, we're going to say, for the sake of the practicing this problem, there's no friction on the mass. So it says the spring is relaxed in the first diagram, so it's at its equilibrium position. So 10 meters is the equilibrium position. So Slim Jim is pulling with how much force now? That would be 0 newtons at that moment. Well, Slim Jim then stretches the spring as shown. Calculate the spring constant. Okay, so he uses 2,000 newtons and he stretches it from 10 meters to 15 meters. So we know that spring constant is newtons per meter. So we have a force of 2,000 newtons being applied over a distance of 5 meters. So we can find the spring constant by dividing 2,000 by 5. And we get 400 newtons per meter, which is our spring constant. Alright, as Jim stretches the spring, does the force of the spring increase, decrease, or stay the same? The further he stretches, the more force he has to apply. So since force equals mass times acceleration, as he stretches the spring more and more, the force increases, the acceleration of the mass would also increase. Slim Jim releases the mass and it vibrates back and forth. Calculate the period of the spring. So we're going to use the formula T equals 2 pi times the square root of m over k. And we know that our mass is 6 kilograms and our spring constant is 400. So we're going to go ahead and plug that into the calculator. 2 pi times the square root of 6 over 400. And we get 0.77 seconds. Alright, what is the amplitude of the spring's motion? Since it was at its resting position of 10, from the equilibrium position to one end, one extreme, so from 10 meters to 15 meters would be the amplitude. So that's 5 meters from the center. Where is the acceleration a maximum? Give the position. Alright, so it could either be at, when it's completely stretched out here at 15 meters, or when it's completely compressed, which will be 5 meters past, so right here, 5 meters past, or before the 10 meter or equilibrium position mark. Where is the kinetic energy a maximum? That would be in the middle at the equilibrium position of 10 meters. Remember that at 15 and 5 meters, we have our maximum potential energy, which means through the center, all of that potential energy gets converted into kinetic. Where is the potential energy a minimum? That would be at the same spot, at 10 meters, because we have no potential because we have all kinetic. How far does it move from side to side? It moves from 5 to 15 meters, so that's 10 meters from one side to the other. How long does it take to get to the other side? Well, if it has a time period of 0.77 to go there and back, if we halved that, it would give us the time to go just there. So that would take 0.385 seconds.